Hello, today I'd like to do a quick short review on integration by parts. This is the section 2.1 of your Chimera book. This is chapter 2, section 2.1, integration by parts of your Chimera book. And I'll just go over the basic thing and one quick example just to remind you what integration by parts is. So the basic formula looks like this. Is the integral of u dv equals uv minus the integral of v du. So we saw in class how we can obtain this formula by trying to understand or walk back the product rule of derivatives. I'm not going to spend time on this. If you look at your Chimera book, it has this development. It shows you how this came on the IBP formula. And so a quick example here is if you see an expression that looks like a polynomial multiplied by some trig function, then this is a good technique to apply. We let u be x squared, and dv now is the rest of that integrand, sine of x dx. So because u times dv should give us the whole integral. All right, the whole expression in here. So that we could use that for this part. And then we're going to calculate v. We're going to calculate du because we already have u. And we're going to do du and we'll have v. So that's basically what we're going to do. Okay, so du, if u is x squared, then du is 2x dx. And if dv is sine x dx, then v is antiderivative of sine x, which is minus cos x. We can ignore the plus c part because it is really redundant. You can check that by following through adding the plus c if you want to. So this integral now equals the integral of u dv, because u is x squared and dv is sine x dx, so that's what this is. This is uv minus the integral of v du. Now what's u? U is x squared. V is minus cos x. I'll put this in parentheses because we have to multiply them. Minus the integral of 2x dx minus cos x times 2x dx. That's 2x times minus cos x dx. Okay, I'll bring this up here. That gives us minus x squared cosine x. This is this part. And I have a minus here. I have a minus here. And with this minus, it gives me plus the integral of the integral of 2x cos x dx. Now the main idea here is that the expression that we find after one step seems to be a little bit simpler than the original expression we have here, because this had x squared, okay, and this one has a linear function 2x. So we're going to do the same u dv for the second part. So to compute integral of 2x cos x dx, we'll let u be 2x and dv be cos x dx. Then du becomes 2 dx and v becomes sine of x, because the antiderivative of cos x is sine x. So then this expression is the integral of u dv, which is uv, that's 2x sine x, minus the integral of v du, 2 sine x dx. v is sine x du. Okay? Now 2 sine x dx integral is minus cos x, or minus 2 cos x. So that gives me 2x sine x minus 2 cos x minus 2 cos x. That makes it plus. And I'm going to ignore the plus because I'll add it at the end. So let me come back to my blue pen. So the integral of x squared sine x dx is minus x squared cosine x, which is this guy over here, plus this integral here we already calculated to get this expression here. Okay, so I'll put that for that integral, plus 2x sine x, 2x sine x, plus 2 cos x plus c. So that's the integral of x squared sine x dx. Okay, and if you go back, if you go to your Chimera book, that's the integral formula. Okay, and it tells you here, this remark tells you what the steps look like. And here are a basic example. Here's one, x sine x, and I would like you to read that. And we had a few examples that we did in class also. Please read those. And this is another one that has some numbers here in front of x and some numbers here in front of x. The process is similar, but we have to just be careful with the numbers. When we do antiderivative of sine of 4x, it gives us minus 1/4 cosine of 4x. Okay, so just we need to, it's just the bookkeeping stuff. And there are a few more complex problems we did in class. So I did skip this tabular integration because it only usually applies to a certain kind of problems. But it's a good idea to look at it also. And here's a good example there. But when we have inverse trig functions, we need to know which one is u, which one is dv. The more convenient case, when you have natural log of x, u is the natural log of x and dv is the polynomial, because when you differentiate this natural log of x, it becomes simplified. Even though integrating x cubed x to the fifth makes it x to the sixth over 6, when you multiply the two, when you multiply u dv, things simplified. Okay. When you multiply v du, they get simplified. All right. So there are a few examples like that. Here, natural log of x. A good example. A few examples in here. So that's just a quick review on integration by parts. I hope it helps. And thank you.